Assalamu alaikum warahmatullahi wabarakatuh and very good evening. I am Suhail Abdurrahman. I am supervised by Dr. Muhammad Faid bin Yahya. It is my privilege to be standing in front of both of you, Associate Prof. Dr. Ahmed Zaki and also Dr. Muhammad Khairi. My title is Simulation of Manipulator Control System for Drilling of Top Cover Component of Airplane. The content is Introduction, Literature Review, Research Methodology, Results, Conclusion, Future Work, and also references. So I will talk first about the title. The title is consists of five aspects: the control system, which is the fundamental aspect; a robot manipulator, which is the technology aspect; drilling, which is the application aspect; top cover component, which is the workspace where the application will be done. Uh, then I will go to the introduction. First, before I go to the introduction, I must talk about the background of this project. Controlling the robot manipulator is concerned with lots of things, which is like development, the velocity, position, acceleration of the robot manipulator, either to control the effector or all the joints for the robot. Drilling application is one of the most important application that is used in robotic manipulator, mainly used to improve the whole quality of the drilling. As we are talking about drilling for airplanes, so airplanes is made for titanium. Titanium is a small substance that can some small substance that is difficult to be drilled by laborers. So it is labor intensive and time consuming operating, and consistency of hull quality is poor, which lead to rework. So we need to automate it. The motivation in recent years, numerous of control authors and large number of control applications were presented mostly regarding controlling the robot manipulator. The manual drilling is an outdated process to be used in manufacturing, especially in airplane fields. The drilling done manually, it is the small particles that is comes out from the holes can be inhaled by the workers and adversely affect on their health. The problem statements, we can get the problem statements and then we can get the objective from this problem statements. The problem statements is generating the mathematical model of 6-degree freedom robot. It is difficult due to the non-linearity of the system. Some methods used for controlling 6-degree of freedom robot have low accuracy for drilling application. Difficulties in generating the trajectory path planning. We can get the questions, which are how to get the mathematical design of the robot, how to control the robot's effector position when controlled to simulate the drilling on top cover component, which is circle shape, how to create the path planning using circle equation. The objectives are to obtain the mechanical design of the robot manipulator using SolidWorks and semi-mechanic tools, to develop BD fuzzy logic controller to control the position of the robot manipulator, and then to investigate the requirement of path planning and simulate drilling on the top cover component of airplane, which is a circle shape using Kukai robot. The scope will be to study about control methods used to control robot manipulator, and also to create the mechanical design using Simulink and semi-mechanics tool. Study the trajectory path planning and how to create a path using circle equation, and then simulate the performance using MATLAB and also Simulink environments, and we will use CopyLSM to simulate the drilling. One limitation I want to focus on each is the drilling effects of force and the pressure, and also the pressure on the surface is not considered in this project. Here we'll talk about the lecture review in fast. I talked about lecture review, which is you have to talk about the previous studies that has been done in controlling robot manipulator. I talked about BID as controller, fuzzy logic controller, SMC, which is sliding mode controller, neural network controller, LQR, linear quadratic regulator, and also I talked about some advancement that can be added to some of the controllers in order to enhance either the robustness, flexibility, or the output of the control. After that, we can make comparison between these controllers according to 5 criteria: system compatibility, design complexity, optimal configuration, flexibility, and robustness. The last two things, which are the most important, flexibility and robustness, we can see that fuzzy logic controller has high flexibility and robustness in comparison with other controllers, which are like neural network. It has a high flexibility and low robustness. So we choose fuzzy logic as controller. Also with advancement, we choose BD fuzzy logic for this project. For the trajectory path planning, there is I talked about two methods which are joint space and Cartesian space. We have another method like ditch path and also the CAD path planning. I choose Cartesian space because it has a high complexity and calculation involved is high, but the efficiency is also as high. So the problem with Cartesian is the singularity, which means that end effector cannot reach some places. Here is the method selection and knowledge gap found from literature review. We choose robot manipulator, which is PD fuzzy logic controller, and the path planning is Cartesian space method. Now I will start with the research methodology. In this flowchart, I summarized all the points where I will be talking about in research methodology and how it can be achieved by each objective. First objective, which is to obtain the mechanical design of the robot using SolidWorks and the sim mechanics tool. It will be achieved by drawing the robot in SolidWorks, obtain the mechanical design using sim mechanics, and convert the mechanical design to SimScape to be used in Simulink. The second objective is to develop a PD fuzzy logic controller to control position of the robot manipulator. What I did is design the blocks of the robot in the Simulink. After I did it from the sim mechanics, the previous step. After that, I designed the PD controller with unit step function. And then I get the output of the PD controller. After that, I add fuzzy logic. Here, the output of the PD will be going to the input of fuzzy, and then the output of the fuzzy will go to the scoop in order to get the signal controlled 2 times. So it is controlled by the PD and then controlled by fuzzy logic. And then I compare the two results of PD and PD fuzzy. After that, I choose PD fuzzy controller as controller of my robot. After that, the third objective, which is to investigate the requirement of path planning and simulate drilling on top cover component of airplane circle shape using OkayObot. Designing the top cover component of airplane circle shape, this is the first one in CopyLSM, and set up the CopyLSM simulator. Actually, I used the project that we did in the last lab with Professor Zaki, and I make some modification for the code, and I get the result. Generate the trajectory using circle equation, which is x is equal to r cosine theta, and then OkayObot simulate the drilling process. This is the research methodology, and now I will go to step by step. This is the mechanical design obtained from Simulink. We can see here the joints of the robot, and also how we can control the gravity of the robot, how it works, how it moves. Here is the PD controller, how it is designed to control the joints of the robot by using 3 PD, one PD for each joint. Here I added the fuzzy logic controller. Actually, I find a lot of difficulties in fuzzy logic controller as it is my first time to work with fuzzy logic. I start learning fuzzy logic controller after my previous sem between the semesters in the break. I start learning about fuzzy logic and how to make the rule base and membership functions. I had lots of difficulties to set the scale of the membership functions, and also how to set the rule basis. Actually, I used 5 membership functions, and I get 125 rule bases. In order to make the robot here, I will talk about how the robot is going to go through a circle shape. In order to make a robot run in circle path, we create path points in a circle shape, find the x-axis and y point for every 9 degrees using the equation here, which is x naught is equal to r cosine theta and y naught is equal to r sine theta. Here I consider the center as 0, 0. If it is not 0, 0, we can say that the equation will be x is equal to x position plus r cosine theta, or y is equal to y position plus r sine theta. It depends on the place of the surface. Here this simulation of the setup simulation of the robot in CopyLSM. The simulation will be like this. Use the simulation CopyLSM to obtain the joint angles by using the inverse kinematics model that is inside the robot already in CopyLSM. Record the velocity, acceleration, and the position, and get the CSV file. and get the data and obtain the graph for all joints in one picture. Then experimental procedure will be like, first do the path of the circle as a waypoint. Second, set up the copyrealism simulation with the drill bit. Third, let the robot follow the path with constant velocity. In here, the last part, which or the one before the last, which is the result. In the controlling design, I depends on the step responses in order to evaluate my result or make an analysis like either quantitative or qualitative. I talked about overshoot, unit step, settling time, and steady state error. Here, the output of the BD controller. We can see here the first joint has a high overshoot, which is about 24%, and the second one got a lot of oscillation, and also the settling time takes long time. The second one got overshoot, and the settling time also takes a long time, but the rising time in both and the three of them are a little, which is 0.4 something. 0.04 for second joint and 0.2 for third joint for rising time. Here with the BD fuzzy controller, we can see there is no overshoot, and settling time is too small, which is around 1 or 3.6 second or less than that. The problem is with the rising time; it takes long time to make to rise or to rise to get the settling time. So rising time here is about 1.16, and there is no steady state error, and the overshoot is too small. For getting the path of the robot for each point, I used the circle equations. X are cosine theta, as is mentioned in the methodology. I made this figure using MATLAB, and I get the 4 points as points for drilling. So robot will drill here, and then here, and then here, and then here, with 9 degrees for each between each point, and with a stop of 6 seconds as drilling simulation. This is the result getting from the robot. This is the position of the robot for each joint 0, joint 1, and joint 3, and joint 4, and here the velocity of each joint. We can see here the joint number 0 is constant, going constant until it finish, with a very high velocity due to at the end of the robot working, it goes up. After that, here the acceleration, we can see it is steady in a zero acceleration. Here is the error, which is the maximum error is approximately 0.011, and the minimum is 0.0002, as stated in the graph. Now I will simulate and run the robot. Okay, as we see the simulation, the conclusion of this report is the research concerned with the controlling Kukai robot, controlling the position of the robot, has many ways. In this report, we use BD fuzzy logic controller, and for path planning, we used the Cartesian space. A suitable path planning method is used, which is Cartesian space method, in order to let the end effector goes from points to points and determine the specification. The drilling process will be simulated, which means the rotation of the drill bit, the pressure of the robot drilling, and the hose opening is not performed. So we can get that all the objectives has been achieved successfully. And for the future work, as we know, this is only a simulation in a software, is not a real drilling. In the future, in the further studies in this situation, the real drilling robots should be trying to drill in a real life with a real part of top cover component by using all the programming code in Copyrealism software and other softwares that can help improve the drilling process and automate it. This is the references, and thank you so much for listening to my presentation. I hope I could deliver my ideas clearly. And assalamu alaikum wa rahmatullahi wa barakatuh.